Here's a review for the test on transformations. So you have seen this chart before many times. This is the chart that organizes all of the transformations that we have learned so far. So we started with reflections. Here, the chart goes over how we change the coordinates when we do a reflection. In the x-axis, the y-coordinate changes sign. In the y-axis, the x-coordinate changes sign. In the origin, both change sign. And in y equals x, we switch the coordinates. Remember, when you have a line, when we're reflecting over a line x equals 3 or y equals 1 or something like that, we have to use this method here, a tool or a ruler. And that's where you count the units to the line of symmetry and then replicate that distance on the other side. Okay. Then the next transformation that we went to were translations, down here. So remember, translations, look at the word translation. Trans means to move, and lation means to across. So if we're translating a figure, a point, we're moving it across the coordinate plane. And you can either go up or down, or left and right. Okay? If we're going left, we are subtracting from x. If we're going right, we add to x. If we're going up, we add to y. And if we go down, we subtract from y. Okay? And this right here is called our translation statement. And that tells us for every x, y coordinate, we do this to x and we do this to y. Okay? Or the problem could just say, translate this figure 3 units right, 4 units down, in which case you would either have to write a translation statement or just move the figure and then draw the new one. Okay? The third one that we learned about were rotations. Okay? And we need to know the angle that we are rotating, the center or the point that we are rotating around. Remember when it said about point? That always indicated where the center was. And then we had to find the direction. Are we going clockwise, which is like this, or counterclockwise? Or counterclockwise, which is like this. Okay? And then, once we knew the angle, center, and direction of the rotation, we were able to rotate the figure either using the jacket rule, in which case we just mess with the coordinates, or we would draw with a protractor. On the test, you will not have to draw with a protractor. So just memorize the jacket rule. Okay, and then on the last one, dilations. This is the one you need to teach yourself over break, and we're going to go back over it when we come back. It's not going to be on the test. It is not on the test. So let's do a sample problem from today. This will be on the test, okay? I don't know if I'm supposed to tell you this or not, but this is going to be on the test, so you really need to listen up, okay? Here we have triangle JKL. It's shown on the coordinate plane below. The question says, copy the coordinate plane and triangle JKL as shown onto the grid in your student answer booklet. Okay, that's for MCAS. The first thing we have to do, triangle JKL is reflected over the y-axis. As soon as you see the word reflected, you know that you need to find the boss, okay? So this question tells me, since I'm reflecting over the y-axis is my boss. And I will be reflecting the image over the y-axis that way, okay? So on your grid, draw triangle J prime, K prime, L prime, the image of JKL after it has been reflected over the y-axis. Okay, so we need to reflect this over the y-axis. Remember, there's two ways we can do it. We can either count, in which case we start at L, we count 1 unit over to the y-axis, and then we replicate that distance on the other side, and we find L prime. We do the same thing for J. Count 1, 2, 3, 4, 5, 6 units to the y-axis. 1, 2, 3, 4, 5, 6 units over. This becomes J prime. Or K, we do 1, 2, 3 units over to the y-axis, 1, 2, 3 units over, K prime is here. We connect our points, and we find our points this way. We look on the figure, and we find, okay, let's write the original points up here first. We have J is negative 6, 2. K is negative 3. Positive 3, positive 5. And L prime became positive 1, positive 3. Okay? So which coordinate changed? If y was the boss, we multiplied x by negative 1. And that's how we found our points, either from the picture, or we can just start with the original points and multiply the x coordinate by negative 1. Because y is the boss. So those are the two ways that you could have reflected this shape over the y-axis. And then found the coordinates. Okay, so the next part of the question says, triangle JKL is rotated 90 degrees clockwise about the origin. So J prime, K prime, L prime. Okay, so the prime, the new one that we just reflected over the y-axis, is rotated 90 degrees around the origin. So now, if we rotate 90 degrees clockwise around the origin, let's just use the jacket rule. So we have J is positive 6, J prime is positive 6, 2, K prime is positive 3, 5, and L prime is 1, 3. Okay? So remember the jacket rule? First, we take off the jacket and we switch the jacket around, right? So we don't worry about the sign. We just switch X and Y, and we get 2, 6. So K double prime, 5, 3, L double prime, 3, 1. Are we finished? No, because we have to put the jacket back on. And when we say we put the jacket back on, it means we assign the proper sign as per each quadrant. Okay? So, if we rotate this figure 90 degrees clockwise about the origin, we're going to be going 90 degrees clockwise about the origin. We're going to fall into the fourth quadrant. In the fourth quadrant, X is positive and Y is negative. So we have to negate all of the Y's up here. And our new points become, these. So we have J double prime. Let me erase this part. Hold on just a moment. And then this becomes our new figure, L double prime, K double prime, J double prime that we found right here. Okay? So now we have done this part. It has been rotated 90 degrees clockwise, and we labeled our vertices. Now suppose the vertices of J double prime, K double prime, L double prime are reflected over the y-axis. So now we're reflecting them over the y-axis, and then reflected again over the x-axis. Okay. Do the vertices of the resulting triangle have the same coordinates as the vertices of triangle JKL? Let's see. So remember, if we're reflecting something over the y-axis and then over the x-axis, let's just work with the coordinates from this point on, okay? So we are reflecting J double prime, K double prime, L double prime over the y-axis first. When we reflect over the y-axis, we multiply x by negative 1, right? Only x is going to change. So we get J triple prime becomes negative 2, negative 6. K triple prime becomes negative 5, negative 3. and L triple prime becomes -3, -1. So this is when we reflected over the y-axis. And our figure will look like this. Now let's reflect these points, this figure right here, over the x-axis. So we have J, 4th prime. If we reflect over the x-axis, we multiply y by -1, okay? And we get -2, 6. K 4th becomes -5, 3. And L 4th becomes -3, 1. Okay. So these, let's see if these match up with our original points. If they do, then we have the same coordinates as the vertices of the regular triangle. Let's see. -2 here does not match up with this. This here does not match up with this. And this here does not match up with this. Therefore, the resulting triangle will not have the same coordinates. And you can see the chart above. Oh, that's messy, hold on. You can see the chart above.